welcome back. Let's continue. Have a good Friday, have a good weekend. I'm making some video in my language, Danish, about the history of the cars. So I was reading about the wheel, the invention of the wheel. That's very important in the history of the car because we need some wheels on a car. These spokes, they are very important too because wheel only with solid wood, that's not so good. So they did inventing the spoke. They did invent the spoke actually a long time ago, like 200 years before birth of Christ, year 0. So that's like more than 2,000 years ago. So let's read about it then. I will make a video in my language, Danish.
Spoke. A spoke is one of some number of rods radiating from the center of a wheel, the hub where the axle connects, connecting the hub with the round traction surface. A spoked wheel on display at the National Museum of Iran, in Tehran. The wheel is dated to the late 2nd millennium BCE and was excavated at Chakazanbil. The remains of a pair of cart wheels with metal axle assembly. The term originally referred to portions of a log that had been riven, split lengthwise, into 4 or 6 sections. The radial members of a wagon wheel were made by carving a spoke, from a log, into their finished shape. A spoke shave is a tool originally developed for this purpose. Eventually, the term spoke was more commonly applied to the finished product of the wheelwright's work, than to the materials they used. History. The spoked wheel was invented to allow the construction of lighter and swifter vehicles. Earliest physical evidence for spoked wheels were found in Sintashta culture, dating to c. 2000 BCE. 1. Soon after this, horse cultures of the Caucasus region used horse-drawn spoked wheel war chariots for the greater part of 3 centuries. They moved deep into the Greek peninsula where they joined with existing Mediterranean peoples to give rise, eventually, to classical Greece after the breaking of Minoan dominance and consolidations led by pre-classical Sparta and Athens. Neo-Chalcolithic / Protohistoric period, 1800 to 1200 BCE, Note 1. Paintings in various regions of India such as Chibanullah, Bhojnath Nulla, Cappadocia, etc. depict the usage of chariots with spoked wheels. 5, 6. Celtic chariots introduced an iron rim around the wheel in the 1st millennium BCE. The spoked wheel was in continued use without major modification until the 1870s, when wire wheels and rubber tires were invented. 7. Construction. Spokes can be made of wood, metal, or synthetic fiber depending on whether they will be in tension or compression. Compression spokes. The original type of spoked wheel with wooden spokes was used for horse-drawn carriages and wagons. In early motor cars, wooden spoked wheels of the artillery type were normally used. An ox wagon in Aliwal North, South Africa. Note the 3 missing spokes and the metal tire. Wooden spoke wheel with metal rim from antique truck on display in underground Atlanta. Metal tension spoked wheel from Abicycle. In a simple wooden wheel, a load on the hub causes the wheel rim to flatten slightly against the ground as the lowermost wooden spoke shortens and compresses. The other wooden spokes show no significant change. Wooden spokes are mounted radially. They are also dished, usually to the outside of the vehicle, to prevent wobbling. Also, the dishing allows the wheel to compensate for expansion of the spokes due to absorbed moisture by dishing more. 8. Tension spokes. for use in bicycles. Heavy wooden spoked wheels were replaced by lighter wheels with spokes made of tensioned, adjustable metal wires, called wire wheels. These are also used in wheelchairs, motorcycles, automobiles, and early aircraft types. Some types of wheels have removable spokes that can be replaced individually if they break or bend. These include bicycle and wheelchair wheels. High-quality bicycles with conventional wheels use spokes of stainless steel, while cheaper bicycles may use a galvanized, also called rustless, or chrome-plated spokes. While a good quality spoke is capable of supporting about 225 kgf, c 500 pounds force or 2,200 newtons, of tension, they are used at a fraction of this load to avoid suffering fatigue failures. Since bicycling wheelchair wheel spokes are only in tension, flexible and strong materials such as synthetic fibers are also occasionally used. 9. Metal spokes can also be ovalized or bladed to reduce aerodynamic drag, and butted, double or even triple, to reduce weight while maintaining strength. A variation on the wire-spoked wheel was Shioga's tension disc, which appeared superficially to be a solid disc but was in fact constructed using the same principles as a normal tension-spoked wheel. Instead of individual wire spokes, a continuous thread of Kevlar, aramid, was used to lace the hub to the rim under high tension. The threads were encased in a translucent disc for protection and some aerodynamic benefit, but this was not a structural component. Usual spoke diameters: 10. Wire gauge diameter section area 15 G 1.8 mm 3.24 mm 214 G 2.0 mm 4 mm 213 G 2.3 mm 5.29 mm 212 G 2.6 mm 6.76 mm 211 G 2.9 mm 8.41 mm 210 G 3.2 mm 10.24 mm 2. Tangential lacing. Wire spokes can be radial to the hub but are more often mounted tangentially to the hub. Tangential spoking allows for the transfer of torque between the rim and the hub. Tangential spokes are thus necessary for the drive wheel, which has torque at the hub from pedaling, and any wheels using hub-mounted brakes such as disc or band brakes, which transfer torque from the rim to the brake in the opposite direction, via the hub, when braking. Wheel building. Constructing a tension-spoked wheel from its constituent parts is called wheel building and requires the correct building procedure for a strong and long-lasting end product. Tension spokes are usually attached to the rim or sometimes the hub with a spoke nipple. The other end is commonly pinned into a disc or uncommonly bent into a Z to keep it from pulling through its hole in the hub. The bent version has the advantage of replacing a broken spoke in a rear bicycle wheel without having to remove the rear gears. Wire wheels, with their excellent weight-to-strength ratio, soon became popular for light vehicles. For everyday cars, wire wheels were soon replaced by the less expensive metal disc wheel, but wire wheels remained popular for sports cars up to the 1960s. Spoked wheels are still popular on motorcycles and bicycles. Spoke length. When building a bicycle wheel, the spokes must have the correct length, otherwise there may not be enough threads engaged, producing a weaker wheel, or they may protrude through the rim and possibly puncture the inner tube. Calculation. For bicycle spokes, the spoke length is defined from the flange seat to the thread tip. For spokes with bent ends, the nominal spoke length does not include the width of the spoke at the bent end. For wheels with crossed spokes, which are the norm, the desired spoke length is where d equals distance from the center of hub, along the axis, to flange, for example 30 millimeters. R1 equals spoke hole circle radius of the hub, for example 19.5 millimeters. R2 equals half of effective rim diameter, ERD, or the diameter the ends of the spokes make in a build wheel. See discussion attached to this article for explanation of the rim, for example 301 mm. R3 equals radius of spoke holes in the flange, for example 1.1 mm. M equals number of spokes to be used for one side of the wheel, for example 36/2 equals 18. K equals number of crossings per spoke, for example 3 and A equals 360 degrees K/M, for example 360 degree asterisk 3/18 equals 60 degrees. Regarding D, for a symmetric wheel such as a front wheel with no disc brake, this is half the distance between the flanges. For an asymmetric wheel such as a front wheel with disc brake or a rear wheel with cane derailleur, the value of D is different for the left and right sides. Dotter is the angle between 1. The radius to a nipple hole in the rim to which a spoke is attached, and 2. The radius to the flange hole holding the spoke. The spoke crosses either 1, 2, or 3 oppositely pointing spokes depending on the lacing design. On the flange, the angle between the radii of adjacent holes is 360 degree /M, for equally spaced holes. For each spoke crossed, the hub is rotated with reference to the rim one angle between adjacent flange holes. Thus, multiplying the angle between adjacent flange holes by K gives the angle A. For example, a 32-spoke wheel has 16 spokes per side. 360 degrees divided by 16 equals 22.5 degrees. Multiply 22.5 degree, angle between adjacent flange holes, by the number of crossings to get the angular. If 3 crosses, the 32-spoke wheel has an angular of 67.5 degrees. Regarding R3, the size of the spoke holes in the flange does not matter for the needed spoke length. This term removes the effect of the hole size. Since the holes are usually small, just over 2 mm in diameter, the effect is small and in practice matters little. For radially spoked wheels, 0 crossings, the formula simplifies to the Pythagorean theorem, with spoke length L plus R3 being the slope, R2 minus R1 being the base, and D being the rise, or solving for the length derivation. The spoke length formula computes the length of the space diagonal of an imaginary rectangular box. Imagine holding a wheel in front of you such that a nipple is at the top. Look at the wheel from a long thesis. The spoke through the top hole is now a diagonal of the imaginary box. The box has a depth of D, a height of R2 R1 cos, alpha, and a width of R1 sin, A. Equivalently, the law of cosines may be used to first compute the length of the spoke as projected on wheel's plane, as illustrated in the diagram, followed by an application of the Pythagorean theorem. See also bicycle wheel, spoke nipple, spoke wrench. A flat view of a crossed wheel with one spoke visible spoke shave. Wheel building. Wire wheel. Notes. New May 1800 to 1200 BC.
Good. Let's stop the video. I will read another one.